Yeah, smiling evening to all of CoderRange community members. So today I'm going to start off with an agenda that is our system design. So before I start off with system design is what we are going to discuss today. So I'm going to talk about the problem and I'm going to talk about how it's actually solved, what is the key benefit of the system design understanding here. Uh, so today I'm going to demonstrate a live proven learning that we all have to do in system design is something crazy that has happened to our deeper system failure analysis that I'm going to do today. Okay. Before I talk about this system failure analysis, I'm going to talk about exactly what was the problem and incident. Let me talk about the incident that has happened. Okay. So incident that has happened is that the Paytm UPI incident. This has happened in 2023, and most of us know this, and it's a fact that we are all well familiar about this event, and it's a kind of that is a kind of we have already familiarized this kind of situation we have faced is that Paytm had an UPI incident. It had an UPI delay affecting over 5 crore users. What was the root cause is that they had some inefficient routing in API, okay, and there was a database spike issues. The impact it was that is different, okay, it had reputational damage, but I'm going to talk about what was the root cause about this system design. I hope everybody is going to smile. I'm going to talk about the impact is what was the root cause about the system design. We will take a lot of questions here. A lot of senior architects are here. I know that we can have some kind of understanding. I'm giving you this from my proven experience, from my root cause understanding, and a kind of a real experience from that. I'm sharing you this. Okay. So before I talk about this, why the architects failed here? Because the first thing in Paytm case, 5 crores plus users, it's a millions of UPI requests per minute has happened. And that had need to be proactive scaling. And there was the biggest problem in their business logic was they had done no dynamic routing. So I'll explain about this, why the architects failed and what does that happen. Before I talk about that core design, so let me tell you what was the legacy system design of Paytm. Okay, what was the legacy system design of Paytm, and I will also talk about what was the actually problem. I'll tell you detailed. It will be I want audience. It will be more than it will be taking more than an hour time. I would take more than an hour time in explaining the real problem, explaining the flow of the designs, what have implemented. I want all the smiling coders to make sure you have some little patience to understand, tell you about the problem and how it happened. So let me tell what exactly happened in Paytm scenario of system design. This you can use in your real-time fintech products as well. If you are some from fintech, you can correlate this as well, or any industry domain to understand the similar issues. We all know, we all use Paytms, and we all know how a banking things works. But I'm going to talk about a UPI router that is being implemented in Paytm. That is actually middleware that actually receives your payment and determines a bank to forward that request and routes that request to the destination. And then if the bank is responding, it will take the payment and give you a transaction. That is what UPI router is. And in this Paytm scenario, the main system root cause issue was a payment service provider. So there was a payment service provider, which is a bank that connects your UPI apps to the NPCI network. Okay. So these two are very important. Why I'm talking about these two very important? So you understand the router is a very important person, and the second one is a payment service provider. So they actually talk to NPCI and other networks. Okay. Now I'll tell you the actual architecture what they had. The Paytm actual architecture was, if you are a user, okay, if you try to do some payment of 500 rupees to your friend, it will go to a gateway, API gateway, and that gateway will go to UPI handler, and this UPI handler is actually written in Java based applications, and that will connect to your I told you right, PSP. That is this is how a PSP, payment service provider, right? it connects to payment service provider, and it has a database layer also. And this payment service provider will interact with NPCI. This was a legacy architecture they had. But what was the problem here? Let me tell you this. If an UPI app front end, it can be PhonePe, Google, anything, they interact with the provider service thing, and it can be any bank. So most of you, many of you would have noticed it, I would say, post 2024 or 2024 time, most of you would say there was some kind of migrations we did in UPI. At your phone numbers, there was at symbol added, and it was started with notation I, at Y, it is for S Bank, at SBI, you would have noticed that along with your phone number. Why did that resolution happen? Is that the UPI started working with something called, if there is a PSP bank interactions, that will interact with NPCI. Okay, that is National Payment Corporation of India. And this user bank is where money is there. Okay. Now I will tell you what was the problem. Deeper system design I'll talk about. So what was the deeper system design I'm going to talk about is, now let me tell you the problem. Let me ask the problem to every user here, whoever is thinks as a system design perspective, and you guys can tell your inputs also. Okay. Now I'll tell an example. For instance, if you send 500 rupees to an using UPI, using Google Pay, your Google Pay is linked with some, let's say, Axis Bank as a payment service provider. Okay. And that Axis Bank will forward that request to NPCI. Then NPCI will route it to SBI server. Okay. And you are going to credit that to SBI respective user. This is what happens. Okay. So now in this case, Axis Bank is the PSP for the Google Pay. Correct? Now let's see this example, see this architecture. So let me explain you the core problem. I explained you the core problem. What was the core problem is, I already told here, they had this kind of approach. What was their approach is, the user application will talk to the API gateway, then it talks to UPI handler, and the UPI handler will talk to the banks, respective banks. Okay, and then it will talk to the respective NPCI. But that was not the problem. Here we had the UPI handler was monolithic, and the business logic, the DB access routing was different, and they had a static thing. So they hard coded a bank assignment. Okay, and also there was a lot of issues here. So what actually the system design they started doing is, so let's try to make you the understand of the system design, actual system design of Paytm now. If a user app interacts with the API gateway, okay, it will do an UPI request. Remember this. This is how they design a new system design. There is a UPI requester. This UPI requester will send a Kafka message saying that I got a new request to do a payment, and that Kafka will take as a producer. Okay, and he produces it, and this UPI router will consume that message. Then the UPI router will just send this to the respective bank's PSP. Okay, and if it acknowledges, then that information will be stored in the UPI result handler. In this process, what they are able to do is, as a process, I'll talk about that, why they introduced Kafka and what's the reason. I'll give you deeper on that aspect. This is the new architecture they brought in. So I'll discuss a lot of this here. Okay, why did they do this is because the banks, the UPI requester accepts the request and it will put it a Kafka. Then the router will consume that Kafka message and picks the respective provider and sends the payment. Then the UPI result handler is there. Na? He will consume the result of your transaction. He will write into the DB. This is a core implementation of microservices they implemented it here. And this core implementation is what making Paytm a successful in terms of scaling their users in terms of it. But now most of us will ask this question. If you see this actual architecture, the user app will interact with the API gateway. Then it will interact with UPI requester. As I told you now, UPI requester is this guy, right? This is the main resource service. So this UPI requester will, you can see that it will send a message in Kafka producer. Okay. Now what they have done in Paytm is they've completely migrated this UPI request into Go microservices. Okay. And then the Kafka producer will try to generate a topic, that is, let's say UPI transaction. And here what it does is, this UPI requester, it will try to retry with the respective, it will use retry concept, saying that if the bank's server is not responding also, it will retry for some time, okay, to the UPI router microservice. It will choose. I mean, if you see previously what was happening, is if you have a phone number in Paytm, anything, it will try to route it to all the banks or some kind of business logic they were doing. Now the UPI router microservice, if you are using SBI, then it will go to the respective bank, okay, and then it will get the response. Okay, according to the router microservice, it will go to respective bank. This is the business logic they implemented it. Okay, but if you see now here, UPI requester, it will not wait or block it, never. Its job is to what? It use of Kafka, publish a message, publish some topic and return immediately. Router will consume it and route it and again publish again. Okay, because its job is again publishing it. And then you can see here, the UPI result handler will consume that message of your thing and then write into DB. So this is how an actual architecture happened. Now I'll go flow by step flow, okay, to everyone so that you can understand and you can ask cross questions also. I'm open for that, your questions, guys. So what is the step-by-step flow is, internally in the architecture, what improvement they've done is, the UPI requester will validate the incoming payment request. It will send the topic, Kafka topic, UPI transaction, and the UPI router will consume that, okay, for every transaction, not just successful one, anything, and attempts to process the transaction to the based on the bank TSP. Then it waits for a response. If it gets it, if the UPI router gets anything, if it is success, failure, anything, time mode, it will write that into DB. So who does that is UPI result handler will do that, and that's the final outcome. So this is the implementation. Now the new Paytm architecture has implemented it. Okay, over the previous thing, now this is a microservice based application doing all the implementation. Now the question we will have is that can we have one producers and two consumers? This is a question we should have asked ourselves. And is there any operating system level issues we will face? And is there any going to be, how to prevent this problem, or what type of partitioning topics will be there? And that is all the questions we'll always ask, because no problem, as the topic, our consumers are different separately, so there won't be any much problem here. Okay. Now, before I take you the question from all of you, you can see one of the important concepts. This is what a smiling developer has to understand. Previous architecture of Paytm was UPI switch was basically static routing. They were routing it based on the kind of bank provider and all, static. Now they are doing a router with bank health based routing. That means they are going to microservice. That microservice will do a intelligent routing. Okay, but previously they were using Java and Node based thing. Now they use Go language for high concurrency. Previously they were using a synchronous REST APIs. Now they are using asynchronous and completely Kafka based communications. And previously the main problem they had is there was no circuit breaker and retry on DBs. This was something missing, and the Kafka retries and rate limiting has been really implemented. And database also, scalable databases with all the CQRS pattern has been implemented. Okay. Now this is a core implementations they have done. Now let's say we all are going for an interview, job interview, and imagine an interviewer will ask you this question to all of us. Okay, let's ask this ourselves. Let's say this was system design question. I have demonstrated a real problem of Paytm, and you know what was a legacy architecture and what is a new architecture. Now let's say an interviewer asks you this question. We all are going for something, and they'll ask this question. So in the system level, what is the mistakes and fixes they will have? So let's ask you this question. Suppose in this, especially in this kind of Paytm scenarios, do we need to implement something called retry logic? What do you guys say? We need to implement any kind of retry logics? What kind of problems we will get? Hello? Hello? Yeah, everyone can. Yeah, what kind of problems we will face? You can use chat box or you can use anything, guys. Yeah, what kind of issues we will face here? Okay, so definitely this is not for beginners, guys. This is for someone who is. It's not for beginner means no. It's if you are even a beginner at system design, you can understand this architecture at least by understanding the terminologies. Okay, so coming back to here, the real interviewer will definitely ask you, do we need to use a retry logic in Go? Why? For example, I'll tell you. Suppose you lost UPI request in network failure, and if so, we have to retry to the bank provider and then do that, right? And DB write issues always we have to do DB write, and we missed on some crashes, right? And also Kafka on disk also will happen some issues. Static partitions also will happen some issues, right? So that is the main thing for this kind of business logics we have to implement is retry logics. Retry logic means what? Try the request even after delay. Do you see that, guys? Do you see sometimes whenever you use any of the Paytm or Google Pay or anything, do you see sometimes even after your payment happened, the response status will come for you, or you will get a retry logic happening because it will try to do this retry logic. So if you go to system design in real time scenarios, here they will try to ask this system problems actually, because they will do a request again after some delay, because retry only if it is a temporary failure. If there is a bank temporary failure, they only retry only for that. Okay, and they set a maximum limit there, so they do for three times. Post that, they will tell the bank server is not responding. That is actually the system design questions that they will ask you in these scenarios. Hope all of you getting. And even retry logic for Kafka also, because you retry producing the message, and you should prevent data loss here, especially any transaction should be prevented from that, right? So this is actually they will ask in the system design. If you see the real problem, and this is actually they'll ask, because see, for a user, there's no second chance. You cannot afford to lose 10,000 rupees transaction, correct? There's no second chance, right? So user won't retry immediately because he thinks I have requests, I've sent the money message is lost or whatever it is. So always Kafka overloaded. Generally, what happens in Kafka overloaded, they retry after 5 seconds. Okay, so they retry after 5 seconds. This is what happens. So what did they implement it? Now you might get a question. Now let's say, okay, so thank you for that, Ravi. So in real time, maybe if you are worked in the production level, or if you have worked in any kind of business logic in any real-time system design, you will have one core business layer or core domain layer. This is very important because in Paytm case, the core layer is routing system. Means every time the architect or your senior engineer or someone in the real world, they will talk about, okay, we are working with routing system and we have UPI requester, UPI router, UPI result handler. So this will validate and a Kafka write with retry. Okay, this will read from Kafka and retry with the PSP, that is bank and send result, and this is persistent stored in this. Now the question is, are they going to be near failure? Yes. So how do you prevent that near failure proof? They will ask. So what can Kafka fail? That is also an issue, right? Now in the previous case, 5 crore transactions, 5 crore transactions, what Paytm had a failure. But now even a Kafka can fail, yes. So what a hard code architect or someone who is very expert should understand is that he should understand how to make an architect near always failure proof, because he should think about Kafka also. He should create 3 brokers clusters so that they are replicated the data. They should have OS level understanding. They need to see how many files they can handle, memory tuning. They should use Go services with all retry and circuit breakers and all. So they have to make sure observability is superb, right? This is how they can avoid still the near failure in the future. So this is what actually when a system architect or someone would ask you this question, because he would definitely ask you that. And that is one thing. Now, in a system design, for example, in Paytm, if anyone asks you, how do you use Redis database? If anyone asks, what do you say, guys? Someone here?